Hey everybody, this is Mr. Covey here, and today we're going to be talking about paragraph proofs. So paragraph proofs are an alternative type of proof compared to the two-column proof that you've been using. So two-column proofs are good for learning about how to write a proof, but in more advanced math classes, you'll see a lot more paragraph proofs. So we wanted to talk about that now. The format for a paragraph proof uh, can be thought of as consisting of three different parts. There's the intro, the body, and the conclusion. Uh, in the intro, you want to state your given information. So just like when we do two-column proofs, you want to start out with the given information, any conditions, and also anything you can assume from your diagram. Remember that there's not much we can assume, but there are a few things that we can assume from our diagram. In the body is where you kind of get into the meat of the proof. Uh, in the body, you might do things like solve equations to help with your proof. You might show your algebra steps. And you might use counter examples, which we're going to talk about today. At the end of your proof, you need to have a conclusion, and this needs to be, basically it needs to summarize your proof. There is a symbol you see a lot in conclusions, which is the three dots look like a triangle. That means therefore, and you'll see that a lot as part of the conclusion to a proof. Here are some starters that can help you make your writing a little more fluid. So these are different phrases that you can use throughout your proof. I want you to note this last one in particular. Today we're going to look at how do you prove something that is not true, or prove that something isn't the case. And you do that with a counter example. So we will talk about that today. But keep in mind these phrases if you ever get stuck. Okay, let's get into our first proof here. So as with any proof, there's going to be given information a lot of the time. Start by marking that on our drawing. So angle TXW is a right angle. We can mark that. And angle TYV is a right angle. We can mark that. Again, might not look like that in our drawing, but our drawing might not be drawn to scale. So let's start our paragraph proof. You can start off by saying what is given to us. So it is given that angle TXW and angle TYV are both right angles. In conclusion, angle TXW is congruent to angle TYV since, and then here we have to give our reason, our theorem that we're relying on. Since if two angles are right angles, they are congruent. And that ends our paragraph proof. So again, this is just an alternative to a two-column proof. This next one's a little different. You can see it obviously involves some algebra. So I want you to pause the video real quick and label your diagram. Okay, hopefully your diagram is labeled so that it looks like that. And we can start our paragraph proof. So we can start by just explaining that we labeled the diagram. So based on the given information, the diagram can be labeled as shown above. Always good to label your diagram. Now we need to use a definition. So we need to make explicit what we are doing. So we can say, by the definition of betweenness, and you can use abbreviations in these proofs. I know they get a little long, or you'll see that they do. By the definition of betweenness, we can set up the following equations for equation. Now we need to use our algebra here. And now we can show us setting up and solving the following equation. Based on our picture, x plus 4 plus 2x has to equal 16. So 3x equals 12 and x equals 4. Your algebra does not need to be in paragraph form, just needs to look like normal algebra. Okay, we're not quite done yet though. So since x equals 4, by substitution, because we are substituting x into our expressions, AB equals x plus 4, which is 4 plus 4, which is 8. And BC equals 2x, which equals 2 times 4, which equals 8. Now we're ready for our concluding statement. Therefore, AB, segment AB is congruent to segment BC because if two segments have the same measure, they are congruent. Okay, for this next one, again, start by labeling the diagram. So they tell us angle D is obtuse and angle C is greater than 90 degrees. And they want us to prove that angle D is congruent to angle C. We actually cannot prove this. So we should start by saying this. Based on the given information, we can just say info. This cannot be proven. So this is different. We are not proving that it is true. We are saying that we cannot prove it. And we need to offer some explanation here. So, although both angles are obtuse, they are not necessarily congruent. Okay, now comes the counterexample. So a counterexample is exactly what we're doing here. It's an example that shows that something is not true. So we should state that we are showing a counterexample. So our counterexample, and all we need is one counterexample. So let's say the measure of angle D was 97 degrees, and the measure of angle C was 110 degrees. That's a counterexample that fits our conditions above, yet it is clear that angle D is not congruent to angle C. So our counterexample shows that you can't prove the angles are congruent. I wanted to look at one more proof here. So again, label our diagram with our tick marks and go right into our proof. If B is the midpoint of AC, then segment AB is congruent to segment BC because, and we're kind of relying on the definition of a midpoint here, because the midpoint of a segment divides that segment into two congruent parts. Two congruent segments, let's say. So you'll notice this proof was just one sentence. So if you can fit all the different parts in there into one sentence, that's perfectly fine to do. And that concludes our video on paragraph proofs.